All right, good morning or afternoon, ladies and gents. So here's the deal. Three things you need to do today. Well, four. First, you have to finish that last investigation. If you have not finished that yet, this is not going to make a lot of sense. Now, if you're confused about the last investigation, this should hopefully kind of tie things together, but you got to do that part first. Also, that was due for points, so if it's not actually submitted to me yet, you can still submit it. It's just worth fewer points than it was before, and so you have to deal with that first. Now, this second part is in three parts. First, you have this warm-up that we're going to kind of work through together. That should give you a ton of information. Second, we're going to take some notes together. Sorry, that's going to be long and boring. And then the third thing, I'm going to walk through at least one example with you, maybe two or three, of the actual activity. Now, of course, your homework's going to be to finish that activity. And when we're back together on, let's see, what's that going to be, Tuesday? We will tie everything together and we will push forward. So like your responsibility now is to finish that last investigation. Stop this now if you haven't, go back and do it, and then do these three parts with me. So take notes, obviously, like I'm taking notes, but also if you listen to music, now's the time to turn that off and focus in. So let's do this. Now, obviously, being a video, you can stop, rewind, watch parts again. So if you didn't get it, it's your responsibility to know that you got it. So let's do it. So on this first one, we have to create these mapping and moving lines. And you're going to hear me say this a lot in class over this unit because this is really what this unit's about. You have a triangle in position 1 or a shape in position 1, and we're going to map it or move it along these lines, vectors, circles, perpendicular bisectors into this next place. The big thing is, to keep in mind is that when we're moving it, the first set we're going to study is something we're going to call rigid transformations. Rigid in the sense that we're going to keep these congruent, and we'll cover all this stuff, right? So first thing we have to do is figure out what we're dealing with, how it actually moves, and you should know that from that last investigation, and then draw on the pieces that we actually need. Another thing kind of embedded here is we should figure out what's the pre-image and what's actually the image. Now that part's actually super easy. If you pay attention to the letterings, it tells you everything you need to know. Notice this point is called B, and then over here in the second triangle we have a B prime. That little apostrophe in geometry is called a prime, P-R-I-M-E, and the way you say that is B prime. The prime is always going to be a copy of the original. And so we can right away label this guy, and you should do this with me even if the instructions don't say it. This is going to be the image, which from your notes you should know that's a copy, and this is a pre-image, which is what is the original. And so we're actually going from the left to the right in this case. Now this being a translation, you should know for your investigation that this is actually going to move by something that we call a vector. Now a vector is not a line segment or array or a line. It's different. If you remember from physics, it's different because it has a distance and a direction. It moves in a very particular place in a very particular way, and it repeats that over and over again. To map this, all we really have to do is draw in this vector, which means we got to draw in this this movement from B to B prime. Now again, this is different because it's not going to have an arrowhead that's traditional. It's going to have a single arrowhead. And so a vector has a single arrowhead, but it goes directly from one point to the next. So like this vector should actually occur 3 times, one for each point. So one from A to A prime, and then one from C to C prime. They're snaps in place. Now I know this one's a little confusing because the vectors kind of overlap, and maybe it might be a better idea to at least draw one of these in a different color, but it happens that the vectors sometimes do overlap. So you know also from your investigation that these vectors have to be parallel and they have to be congruent, and so we should probably mark that, and so we can mark these 3 with a congruency symbol, and we can mark them also with a parallel symbol. I know the bottom's a little confusing, but that's just how it goes sometimes. And so that's what we're going to see, at least by hand, how you have to mark these things in terms of how they're transformed. Translation is a very particular kind of transformation. That's like that slide transformation. And so essentially this triangle just slid from like the left to this bottom right position along this vector. Now in terms of noting this vector, and we'll cover this a little bit later too, the vector actually has special notation as well. We start with the first vector, or first starting point, excuse me, to the ending point of the vector, in this case B to B prime, and then the vector symbol is just like the symbol here. We use a one-headed arrow. So like we can call that a vector, but it's also equally okay to call this A prime, or I'm sorry, A prime vector, and the the C prime vector. And those are vectors of movement. Okay, so this is just a warm-up. We're just trying to get some notes in here too. So let's describe the movement of A, B, C to A prime, B prime, C prime. Again, this is what we're going to call the image, which I'll shorten just with an I. I'm sorry, the pre-image here, and the image, which is a copy, denoted by the primes over on the right-hand side. And so, like, it's fair to say, just like in a very simple, common way, that what would really happen here is a triangle ABC slid, see, down and to the right to triangle A prime, B prime, C prime. Now, because the triangle didn't actually change shape, it stayed congruent. The congruency statement is really just naming the triangles. So the pre-image goes on the left, so ABC, and then this is going to be A prime, B prime, C prime. But what's important to note for you is that if I ask you for a congruency statement, that's what we're talking about, okay? So that's a translation. Let's talk about reflection. So reflection is probably the simplest way that you kind of talked about before geometry was just going to be a flip. And so essentially we're taking the pre-image and flipping it to the image. In terms of pre-image and image, notice here that this has to be the pre-image, the PI, because we don't have primes. The image is on the right because we do have primes. From your investigation, you should note that this is not a vector. So it's not a vector because if you note up here, all the vectors are parallel and congruent to one another. Here we have definitely three different lengths. So we have this BB prime line, we have this the C prime line, segment, excuse me, and then of course we have this A to A prime line. I kind of missed on that one. Let me move this guy. Oops. Well, maybe not. Okay, that's close enough. So we have these three lines, but they're not the same distance. They seem to be running in the same direction, but it's not a distance. And so if you go back and like review what you remember from your investigation, what we're actually going to do here is determine a line that serves as a perpendicular bisector. And this right here perpendicularly bisects each of the pieces below. And so essentially this green line is not only going to be at a right angle to the red line, but it's going to cut it precisely in half, hence the congruency marks. Same, of course, with this blue line, which I guess we'll just use one tick mark here, but it's also a right angle. And this pink line, same thing, we got a right angle. Now let's go 3. Okay, and it's cut in half. And so this green line perpendicularly bisects each of these other lines. And if you want to color code this like me, just go grab some yellow pencils. But that's also called a line of reflection. And also is sometimes called an axis of symmetry. Okay? And so definitely three different terminologies for the same thing. So if we want the perpendicularly bisecting line, that's what we're talking about, the green one, the line of reflection, or the axis of symmetry. So in terms of like describing the movement, what actually happened here? Well, triangle ABC flipped to triangle A prime, B prime, C prime. Okay, and so the congruency statement is actually going to be the same one. We start with a pre-image, triangle ABC, and it's going to be congruent to the image A prime, B prime, C prime, which of course will be more interesting if we change up the letters a little bit. We're just using standard notation here. Let's get to the rotation. And so I kind of pre-drew some of the movement lines here. Because we have a rotation, which is essentially turning or spinning, it implies we have to do this on a circle. And so if you note the circles, there's 3 of them because of course it's 3 different points, taking us from the pre-image to the image. Again, note the primes. Pre-image has the non-primes, image has the primes. But if you notice the points, here we have C and we have C prime that are part of the same circle. Same things happen with B and then B prime. They're part of the same circle, he's on the same circle. And then we have this A and this A prime on the same circle as well. And so as this thing is turning, what's actually happening is that the points are essentially spinning on this circle and they're going to stay on the same circle. So it's like 3 different tracks happening at the same time. You'll eventually see this on GeoGebra and it's going to make, I think, a little more sense, which is why we use that program, because we can actually see the motion a little bit instead of having to kind of visualize it. But there's 2 things that actually happen here. One, the circles are a big part of this, and this guy right here, just for noting's sake, this F is called the center of rotation. Okay, which essentially means everything is like orbiting around it, just in the same way the planets orbit the sun. But we have to track the angle as well. Now, if you're not quite sure what I mean, hang on. I think it'll make a little more sense. Like, take this B, this pre-image B point, and consider the angle it forms with the center, and then over to B prime. Okay, so that's going to have some kind of angle, kind of describing it right there. If we track the C to C C to F, excuse me, and then the F over to C, you can kind of tell this angle kind of looks roughly the same. It's obtuse, it's wide, and indeed, if this is an actual rotation, these angles should all be the same. So A goes to F, then A goes to its new spinning point here. That angle is going to be the same as the other three angles, or the two angles, excuse me. And so there's two really important things happening. We have a center of rotation, but also we're going to have this angle of rotation. Okay, and so the angle of rotation that takes like A to the center of rotation F to A prime, that's going to be the same as taking from B to F to B prime, or to C to F to C prime. And so like this angle of rotation's got to stay the same for each one, or you don't have a congruency statement, or you don't have a congruent movement, excuse me. So what happened here? Well, triangle ABC, triangle A, here it is, BC, basically turned about, and so like this phrasing about means it's kind of pinning somewhere. So it turned about point F, some number of degrees to its image, triangle A prime, B prime, C prime. And we're going to actually dig into that in the next section a little more. I just want to give you guys kind of like a big overview as we're digging into like the details, right? And so what should you get from this? What should you pick up before you move to the next one? Well, one, transformations are really all about mapping and moving. And so the way things map and move is very specific depending on what you're actually looking at. Translations, which essentially are sliding along these like vectors, which are kind of like tracks. They're parallel and they're congruent. So the vectors have to be parallel and also congruent. And it's got to be the same for all three. And so it's going to take you from the pre-image to the image, which of course you can tell by the prime notation. Reflections are going to move differently. They're not vectors. They're actually lines of reflections. We flip over line of reflection as we take these mapping lines, the red, blue, and pink. They're going to be perpendicularly bisected by line of reflection, which should make sense if you think about reflection. It's going to be kind of inherently mirroring act. Rotations are different too. They're going to spin along these circles a certain amount of degrees, but it's going to be the same amount of degrees for each point. All about an orbit point, which is like this center of rotation, or in this case, point F. Okay, so that's the overview. You should file this into your notes for review later, because we're going to actually go to a grid next, which is going to be a kind of a change for us, but this is going to be an important part too. Okay, so that's part one. So take a moment, catch your breath. If the sub has not handed you the notes, this is the time to go ask for those notes, and I'll see you guys in a minute.